All right, we're on the fourth video in our series on solutions, and we're going to talk about a couple of miscellaneous topics here. The first one we're going to talk about is Henry's law, and this has to do with the solubility of gas in liquids. So here we are looking at the solubility. This is grams, and this is of a gas in a liquid. So we're doing gas, whoops, one S, gas in a liquid. And we're looking at the pressure. So we're looking to see how the pressure affects the solubility of a gas in a liquid. And on this column, we have the amount of gas that's dissolved per 100 grams of water. And on this axis, we have the pressure. Now, this is a really important law to me because I'm a scuba diver. And Henry's law it helps explain one of the phenomenon we have. I'm going to see if I can tweak this a little bit. In scuba diving, it can be a big sorry, changing my contrast here. It can be kind of a big issue. So I always start off by showing two videos. One of the videos has me diving a wreck that is about 100 feet down, and the other one is me diving 20 feet down with a shark. And I asked the students, which one do you think I was more afraid in or more concerned or more worried about? And many times they often say sharks. Actually, it was the 100-foot dive that was really nerve-wracking for me. The shark dive was quite enjoyable. Well, why was that? So for every 30 feet of water, the pressure increases 1 atmosphere. Now, as I'm sitting on the boat, I'm under 1 atmosphere of pressure. And we have gases dissolved in our blood. We have oxygen dissolved in our blood. That's how we're able to breathe. Our body carries oxygen and carbon dioxide around in our blood. Nitrogen is not, we have it in our blood, but it's not something that we tend to take in and give off. So we usually have a static amount. If you look, if I draw my line up here, and then I bring my line over, I have around 0.0025 grams of nitrogen per 100 liters or 100 grams of water. And blood is mostly, it's water-based. So this is my everyday walking around nitrogen in my blood. So how much nitrogen, if I go down 100 feet, how many atmospheres did I increase by? Take a second and think about it. So every 33 feet, I'm going up 1 atmosphere. So here's 33, 66, 99. And what we're going to see is when I get down to the bottom, I have to draw, let me get a ruler out. I don't like non-straight lines. Got that, and then I have to come over to my axis. So I am just shy of 0.01 grams in 100 grams of water. I basically quadrupled the amount of nitrogen that's dissolved in my blood. Okay, does that necessarily hurt me? Not when I'm down at depth. But what can happen as I come up? If I come up too quickly, this nitrogen will bubble out of my blood and create air bubbles in my arteries and my veins. And if those bubbles get into an organ or they get into my brain, I can get what's called the bends. And you can go from being severely injured to even dying. So the bends is a really serious issue. And why? Because when I go to depth, I dissolve all of this nitrogen into my blood. Well, why does this happen? And the guy who figured this out was named Henry. And Henry's law says that the solubility of gas is directly proportional to the pressure exerted. So what that means is as pressure goes up, solubility goes up. And I do a whole lot of pressure increase when I scuba dive. This is why pop fizzes. When they bottle pop, they put it under pressure. They want that carbon dioxide to go into the pop so that when you drink it, you have the experience of drinking something that has bubbles in it because that tastes good to us. But what happens is when you open that bottle, you'll notice if you look at a bottle of pop, there's no bubbles. That's because when they bottle it, they place it under, high pressures to force the carbon dioxide to go in. And then when you release it, all of a sudden you're bringing it back down to this lower pressure and the gas is going to come out, just like what can happen with the bends. All right, so that is Henry's law. I don't know if we want to do both of the next topics or not. We'll see how we're doing on time. I'm going to start off talking about another topic on the next page. You can see that we have polarity. And I want to talk about polarity when it comes into creating solutions. We have a law that says like dissolves like. Like dissolves like. And what that means is that if you have a solvent and a solute that have the same properties. So we have been talking about dissolving an ionic compound, ionic compound in water. Water, and let's remember, polar means has opposite charges. Has opposite charges. So water is polar and ionic compounds are polar. If you put a polar solute into a polar solvent, they will mix. So this will mix. They are alike, so like dissolves like. Not everything is polar. Things like benzene or gasoline. So let's say gasoline, this is a common nonpolar solvent. And a common nonpolar solute would be motor oil. Motor oil. If you've ever tried to clean motor oil off with just plain water, you know it just doesn't work because what you're doing is you're mixing a polar and a nonpolar. So if you do the motor oil, which is a nonpolar solute with a polar solvent like water, these will not mix. Maybe you have seen your grandpa, it's kind of an old-fashioned way to do it, take gas to clean his hands. These two will mix because they're the same. And remember, nonpolar means that we don't have charges on either end. Gas is just basically carbon and hydrogen in a long chain. And so there's nowhere for the charges to kind of reside. We don't have any differences in electronegativity. So these two will mix and these two will mix. But again, if you try to clean motor oil with water, that's not going to work because you would have a polar solvent and a nonpolar solute. Or if you try to dissolve an ionic compound in gas, you would have a polar solute and a nonpolar solvent. Those will not mix. And that is like dissolves like. The last thing that I want to talk about, and we're going to go ahead and throw this into this video, is conductivity. Conductivity, you know what? I'm going to stop it here. I think we're going to make this its own separate video. So it's going to take a bit. Right, so conductivity in the next video.